Let us see how the Earth's magnetic field works. The field lines defining the structure of the magnetic field are similar to those of a simple bar magnet. The reason why a compass works is more interesting. It turns out that you can think of the Earth as having a gigantic bar magnet buried inside. In order for the north end of the compass to point toward the North Pole, you have to assume that the buried bar magnet has its south end at the North Pole. If you think of the world this way, then you can see that the normal opposite subtract rule of magnets would cause the north end of the compass needle to point toward the south end of the buried bar magnet. So the compass points toward the North Pole. To be completely accurate, the bar magnet does not run exactly along the Earth's rotational axis. It is skewed slightly off-center. This skew is called the declination, and most good maps indicate what the declination is in different areas, since it changes a little depending on where you are on the planet. The magnetic field of the Earth is fairly weak on the surface. After all, the planet Earth is almost 8,000 miles in diameter, so the magnetic field has to travel a long way to affect your compass. That is why a compass needs to have a lightweight magnet and a frictionless bearing. Otherwise, there just isn't enough strength in the Earth's magnetic field to turn the needle. The big bar magnet buried in the core analogically works to explain why the Earth has a magnetic field, but obviously that is not what is really happening. So what is really happening? No one knows for sure, but there is a working theory currently making the rounds. As seen above, the Earth's core is thought to consist largely of molten iron, lead. But at the very core, the pressure is so great that this superhot iron crystallizes into a solid. Convection caused by heat radiating from the core, along with the rotation of the Earth, causes the liquid iron to move in a rotational pattern. It is believed that these rotational forces in the liquid iron layer lead to weak magnetic forces around the axis of spin. It is well known that the axis of the magnetic field is tipped with respect to the rotation axis of the Earth. Thus, true north, defined by the direction to the north rotational pole, does not coincide with magnetic north, defined by the direction to the north magnetic pole, and compass directions must be corrected by fixed amounts at given points on the surface of the Earth to yield true directions. Magnetic fields are produced by the motion of electrical charges. For example, the magnetic field of a bar magnet results from the motion of negatively charged electrons in the magnet. The origin of the Earth's magnetic field is not completely understood, but is thought to be associated with electrical currents produced by the coupling of convective effects and rotation in the spinning liquid metallic outer core of iron and nickel. This mechanism is termed the dynamo effect. Rocks that are formed from the molten state contain indicators of the magnetic field at the time of their solidification. The study of such magnetic fossils indicates that the Earth's magnetic field reverses itself every million years or so, the north and south magnetic pole switch. This is but one detail of the magnetic field that is not well understood.